In this lesson, we will discuss the benefits of code reuse and walk through the steps of how to convert your code for use as a sub-VI. First, we will discuss the high-level benefits of code reuse and how to identify code that should be converted into a sub-VI. Modular code implements functionality in units that are independent of one another, so that any changes that you make to a given module will require minimal changes to your other modules. In LabVIEW, you will implement each code module as a sub-VI. Another major benefit of modular code is that once you create a sub-VI, you can reuse it in multiple locations within a single VI or across multiple VIs. When you create a sub-VI, you must define how that sub-VI appears on the diagram of the calling VIs, and you must define the inputs and outputs of that sub-VI. The icon identifies the sub-VI on the diagram, and the connector pane defines the inputs and outputs of the sub-VI. The icon and the connector pane together correspond to the function prototype in text-based programming languages. Now let's take a closer look at creating icons for your sub-VIs. The icon for a VI helps you to identify it on the diagram of another VI. You should create a meaningful icon for every VI. Sub-VIs with well-defined icons convey more information about their purpose and reduce the need for additional documentation. You should avoid using idioms and colloquialisms when creating your icons because they may not translate well for other languages. For example, don't represent a data logging VI with a picture of a tree branch or a lumberjack. Now let's explore the process for creating an icon. First, we'll click Edit Icon in the toolbar. Note that the default icon is just the name of the VI. Depending on the length of your VI name, the entire name may not fit inside the icon. In the configuration pane, we can change the visual style of our icon. If you have a group of VIs that form an API, you could use the banner icon template to unify their appearance. It's important that you use a consistent style for related VIs. In this case, let's use the blank icon, and then we'll set the background color to white. There are a number of glyphs that ship with LabVIEW NXG. To locate the glyphs that you want to use for your icon, you can either browse or you can search. In this case, I'm going to search for save, and I can use the alignment lines to help get everything aligned on our icon. And then I will search for array. Once you have placed your glyphs, you can rearrange and resize them. You can also change the color for each glyph that you place onto your icon. In this case, since it's an array, I'm going to choose orange to match the color of a double array. Now let's take a closer look at creating connector panes for your sub-VIs. The connector pane defines the inputs and outputs that you can wire to the VI so that you can use it as a sub-VI. The sub-VI receives data from the calling VI at its inputs, passes the data to the diagram, and sends the results back to the calling VI through its outputs. Now let's explore how we can configure the connector pane for our VI. The panel for our VI contains all of the controls and indicators that we can use to communicate with this VI. Keep this in mind as we go into modifying the connector pane. To configure the connector pane, we'll go back to the icon editor. From here, in the configuration pane, we can specify how many terminals we want to see both vertically and horizontally. Note that the glyphs do not resize based on the size of the icon. Let's revert back to our 4x2. To wire controls and indicators to our connector pane, we will go to each terminal and select the input that we want to connect. You can specify the behavior for each input and output on your connector pane to ensure that users wire the SUBVI correctly. To change the behavior of an input or output, select the terminal in the icon editor. In the Item tab of the Configuration pane, select Required, Recommended, or Optional. The font style for the control or indicator changes in the icon editor. Required items are bold, recommended items are plain text, and optional items are dimmed. After you configure the terminal settings for a SUBVI, you can view the connector pane and the behavior settings in the Context Help when you hover over an instance of that SUBVI on the diagram. Click each terminal setting to learn more about it. The default connector pane pattern is 4x2. This pattern provides 12 terminals, 4 input, 4 output, and 4 that could be used for either input or output. If your panel includes more terminals than this, you should consider modifying your code. You should use the terminals on the left of the connector pane for inputs and the terminals on the right for outputs. When assigning terminals, consider how the VIs will be wired together. Now let's discuss the steps that you should take to document your SUBVIs. When a user places your VI onto the diagram of a VI that they are creating, they may want to learn more about your VI and its terminals without having to open and explore it. To create documentation for your VI, select the Document tab in the Configuration pane and enter a description for the VI. To create documentation for a terminal on your VI, select the terminal that you want to document. In the Item tab of the Configuration pane, enter a description for that controller indicator. To view the VI description for your SUBVI from the calling VI, first turn on the Context Help, and then hover over your SUBVI. To view the description for a controller indicator, hover over the corresponding terminal. Now let's discuss how to use your SUBVI and common practices for handling errors in SUBVIs. To place your SUBVI onto the diagram, click and drag the SUBVI from the Project Files tab to the diagram of the calling VI. Suppose you have created a SUBVI that interacts with hardware or performs file I/O. If an error occurs in the calling VI before your SUBVI runs, you may not want the SUBVI to execute its functionality. Place a case structure around the core functionality and wire the error-in cluster to the case selector. Move the core functionality of the SUBVI into the no error case so that it only executes if the calling VI did not pass an error into the SUBVI. For the error case, pass appropriate values to any SUBVI outputs. Code that you develop as a top-level VI may one day be used as a SUBVI. This is a great reuse of code, but you may have made design decisions that were appropriate for that VI as a top-level VI, but not as a SUBVI. For example, you may have placed a display error node on the diagram. This node displays error information to the end user and should really only exist in the top-level VI. For your SUBVIs, you should instead pass the error cluster out so that the calling VI can handle the error. It's also possible to create a SUBVI from a section of code within an existing VI. To do this, you will select the code that you want to turn into a SUBVI, and then go to Edit, Create SUBVI from Selection. You can also do this from the toolbar. After you create a SUBVI, you will often want to clean up the diagram. You have completed this lesson. Here's a summary of what you learned.